Welcome everyone. Welcome to the solution for analyzing customer personality hackathon. The data set and the details have been shared with all of you. You are being given a problem statement over here. You can pause for a minute and read the details, or you can refer to the files that have been shared in the link. The problem statement is customer personality analysis is a detailed analysis of a company's ideal customers. It helps a business to better understand its customers and make it easier for them to modify products according to specific needs, behaviors, and concerns of different types of customers. Customer personality helps a business to modify its products based on its target customers from different types of customer segments. For example, instead of spending money to market a new product to every customer in the company's database, a company can analyze which customer segment is most likely to buy the product and then market the product only to a particular segment. The attributes or the fields that we're going to use over here, please refer to them. The details are available in this particular section. We are going to evaluate your answers on the basis of the number of clusters you find it perfect. Once we have received your submission, we are going to evaluate with our submission and how the performance you are getting. Is it up to the mark, the threshold that we have kept up? On the basis of that, the winners are selected. You're going required to participate and submit your file in the names of IPYNB file, Jupyter file with your name and your name.csv file, that is a submission file. Moving forward, the dataset is not much clear, so we are going to use our Python now. First thing, always import the relevant packages. So packages are matplotlib, cborn, numpy, stop, start. Pandas as pd, import. We are also required in this data set. Here you can see year birth is there. So we also require and date of customers enrollment. We require a date time. I think that's it. So while performing the analysis, if you require any other packages, we are going to update it right away. And also, I'm looking forward that when I display the answer, it should have the maximum width. And similarly for rows also. Done. My dataset name is dataset CSV, as you can refer over here. pd read underscore CSV, and looking forward whether it has been successfully extracted or not. I'm using a head operator. We have got the all the columns that are available. The shape of the data set is 2240 records and 29 columns. There is ID also written, and yeah, 29 columns are there. Checking the structure of it. So maximum of the columns have the data type as integer, and one is floating, one is object. And this object also includes a date time customer and your year birth. What we need to do? We need to convert them into date time. To convert them to date time, you can write down df dot the column name, which is year birth, is equal to pd dot date time dt dot date time okay. Year of birth is not required because year of birth I can see they are all numbers, so that is fine. Year of birth is a number only, no need to convert it. So we will be requiring only and only to create for your age and the customer enrollment. Okay. Now in this data set, what we can do, I can check for the null values. So null values is available only and only in income as compared to the, so if the null values, I think there are very less null values available, we can straight away drop it. It will not hamper our result. To check it out with the percentage, you can write down like this df dot count, and it's only 1% of the values of income is null. Either you can impute by mean or you can drop. I am dropping it. And it has been done. Let us check it out whether still we have any values. So no, 000 now. So it has been successfully dropped. Moving forward, now this is the customer analysis data set. What we require here, we require the age group of the customers. Age and age group is not there. Only year birth is present. Okay. Only year birth is there. Education is fine. Marital status is okay. Income is okay. Kid home, teen home, I think they are one or the same thing. DT we have to convert back to date time, and amount of recency is like how much time it has been there since they last purchased, and how much amount that is in dollars they have spent on these purchases. The number of deal purchases they have done. So number of purchases they have done via web or some deals or some catalog, store, website, and which deals they have accepted. So that is what it shows. If there has been complaint, cost of contact, revenue, and response. Okay. Over here, we are required to create the age group. I can say now creating columns as per my need. I'm looking forward. First is age. My df of age is equal to this data what you have gathered. It is from 2013 to 2012 to 14, the 2 years data we have. So we are going to analyze the customers with respect to 2015. This data set is easily available on UCI repository. You can refer over that platform also for more details. So it is 2015 minus, and year of birth is already your numerical. So it will not have, it will be successfully executed. Let us check again. And you can see age has been successfully created with respect to year of birth. We subtracted 2015 as the last year and subtract the year of birth from that. Now on the basis of the year, let us see the distribution of it. So my SNS dot hist plot my DF of age. That is the distribution we have. So I don't bins equal to 25. We can see there is very few records over 100 also. I think that it would be better if I consider my box plot. Yes, so there are some outliers over here. We have found it successfully. There are some outliers over here. I don't want to keep them. So I will be considering the age group less than 100. Okay. What we have found after creating this column, we have found that there are outliers. We are going to drop it. We are going to drop it later on under the data cleaning section. Drop outliers from age. We're going to drop it later on. So we have found one thing good. And I like to consider, let's assume that we have age as young as we are starting from, so DF of age dot minimum value we have is 19 and maximum value we have is 122. I think let's keep at 80 only. We are going to create some age groups over here. We're going to create another column. After age, it will be age group. For the age group, we'll keep a measure like we are going to consider the points that if my age is less than equal to we can take the range of, let's say, less than 19, or we call it as teens, and with the age greater than 19 and age lying between 39, they are called as adults. And then more than 40, more than 40 less than equal to 59, we can call them as middle age. This is my references. You can keep anything. You can even treat only three groups out of it. It's your choice. And for age more than 60, greater than equal to 60, you're going to keep them as seniors. Okay. This is the reference we are going to put it. So my age group is df.log. I'm using the slicing operator over here. On the left side, I will pass the row query. On the right side, I will name the age group. Simultaneously, it will be created for you. And what is the value I'm looking for? Teens. Okay, and this is your adults, middle age adults, and seniors. So age group. I'm looking forward that my DF of age is less than equal to 19. That are teens. Okay, and my age group where DF is greater than 19 and DF of age group is less than equal to 39. That is adults. If my age group age is greater than 40, okay, greater than 39, and age group is less than equal to 59, and then DF of age group greater than equal to 60, they are all seniors. Equal to 20. Let's write down 20 over here. 40 and less than equal to 59, greater than equal to 60. And there's some error over here. I got it. The error is I have to separate the queries. That's it. Done. Check it out. So in the end, you can find out age groups available. So we successfully created one more column, age and age group. The next thing is that we will be creating few more columns. So I am looking forward total spendings. So we have many amounts available. So DF of total spendings is equal to DF of MNT, its common name, the fruits, DF of MNT wines, DF of MNT fruits and wines meat products, DF of MNT fish products, DF of MNT sweet products, and DF of MNT gold products. The total spendings have been created. Check it out. These are total spendings available. So we have accumulated the information of amount into the total spendings. And I can see there we have kid home, teen home also available. So this is nothing but my children's. Kid home plus DF of teen home. This is the children's we have. Check it out. Children have been created. Okay. And what else we need? Children we have done. We let us see one more thing side by side. How many we have graduates? So DF dot education dot value counts. Graduations we have maximum, and PhD then we have masters we have basics I think, and basic is 10th class below, and second cycle is your till 12th class we have. Marital status dot value counts. Okay, they are very abrupt name available. You can see married and together are nothing but the same information. It does not look good to me, so I'm going to change these things. Married and together I would like to keep as married only. Rest of them they are for sure single, divorced, widow, alone. They are single. Absurd and yellow I am not confirmed. I'm going to keep it as single. It's your choice what you are going to prefer. So together I like to keep as spelling should be correct, or else it is going to create a new value, and rest of them are single. Uh, and done. Check it out again. The DF value counts. Okay, I have what I missed it out. Not rename, should be replace. Or by rename, I think I've changed the column name. Sorry, thankfully no column name changed. So rename will going to change the column name. Replace will change the values. So this have been done. And yeah, married and single. We save the work. Okay, so we have given two types of information, and so we have worked on year birth, get the age from it, amounts, get the amount of it. You can also create a new column, total deal purchase, total purchases, and you can differentiate these things from the rest of them. Taking the help from kid and home, I have taken one more information, and so how many years or months have passed since the particular customer has enrolled to our website for the purchases. So I'm going to also calculate months of enrollment. DF of and month enrollment is equal to, over here we to have to do two tasks. First of all, we have to convert the same thing to date time. So first step is df dot dt of customer is equal to pd dot to date time df dot dt customer. And if you check for the information again, you can check it out that dt customer have been converted to date time. Now from this column, I like to create a new column, month enrollment, which is equal to number of months. Number of months. The logic for that is the logic for that is it is equal to number of months between 2015 minus k dt of customer. The number of months have to multiply by 12, plus I would like to also have one less. Okay, one less as compared to the number of what is the month we get it from there. So this is 4. I should be taking 3 over there. Okay. 1 minus df dot dt customer, df dot dt customer dot dt dot month. It will give you the month number. Check it out. So 4, you can see it's 4 over here. We are going to subtract 1 from it, each of them, and then plus it over there. Okay, so that is the logic. Same logic, copy, paste. Okay. DT customer. Data frame and no episode, DT customer. So DT customer spelling mistake. Okay. Data frame object has no attribute DT. I should be commenting this also. Hmm. Dot DT dot here. Done. Check it out. So we have created a new column, month enrollment. How much time has been spent since particular person has enrolled to the having in the same company or doing the purchases from the same company. Okay. Next thing is, so year birth we have worked on it, marital status we have worked, education, kid home, DT customer we have worked so far, and income I would like to also see the distribution of it. So SNS dot okay. I can now clearly see that there is a thin difference between the salary. There is a huge jump, I think, over there. Okay, let's see more clearly. SNS dot. Yes, there are some outliers, and I like to drop these outliers. I think after 1,10,000 there will be no outlier if I drop it. So we have found two types of outliers, one in the age group and the other is in the income. So for data cleaning we have two tasks. NA though we have done. We have dealt with NA values. So we have income also over here. Drop the outliers means reading the data set DF of age greater than, okay, less than 80. Maybe 80 can help us remove the outlier information, or less than 100 you can keep up. It's your choice. And similar to that we have a age group. Sorry, we have income also. I like to keep the income as less than 1,10,000. Done. Check the above charts again. Are we getting the outliers? Age group. Yeah, we are able to omit the outliers. Similarly, the box plot for income. Yeah, outliers have been removed. So successfully done the data cleaning also. Now I like to see some analysis over here. Let us see the pattern, like how many people spend more and less with respect to mm, uh, j- marital status. So I'm going to create a group. Total records. Okay. Total records. I want to have the information and total amount. So this should be sum, and let's see also average. So this is equal to mean of it. Okay. Sorry. Group by marital status. I think spelling is correct for that. Df dot columns. It is marital status. Types to aggregate. No numerical types to aggregate. Oh, sorry. Here the total amount is nothing but total spendings we have calculated. Total spendings. And sum of the total spendings only. Now it will be taken. So married we have 1422 records and 782 for the singles. Total amount spent by the married people is 8 lakh 84 lakh, sorry, 8 lakh 48,000, whereas is 4 lakh 89,000 for the singles. And similarly, average amount spent by the singles are more. So maybe the reason is that widows are also single persons and they might be taking care of the children. Might be possible. So they are spending more. So singles are spending more. We create a pie chart for it. So PLT dot figure. I'm going to create all three in a single window. So I want one row, three columns, first chart, and your PLT dot pie chart. I have in the pie parameters as your labels and X, two different things we have. So X, I like to keep it as my marital group. So it is the values, that is total records I have, and labels I like to keep as marital group dot index, and label is the index. Let us keep the colors also, orange, green. Anything else I require? Yeah, shadow. PLT dot title. This is your total records of marital group. Total records of, okay, let's keep it dynamic. I might be requiring analysis later on also. So marital group dot index. Marital group dot index dot name. Okay. So copy, paste, paste. And finally PLT dot show. What I want the next two pie charts. In the next two pie charts, I want this should be second position and that should be third position. I want the next group should contain your total spendings. Okay, total spendings, and then sorry, it is total amount, and then is your average amount. Okay, so we can also write it down. It is total records, it is total amount, and average amount. Yeah. So what we learn from here, that the figure gives us the same thing, the values that you have extracted for that. I can now clearly see singles are giving on average more business to the company as compared to the whole. So this is with respect to your only if we have gathered data with respect to, and this is the analysis we are doing, EDA. And this first step analysis what we have done is on the marital status. I will perform the analysis also. Now you can put up any other columns. I have already practiced a lot, so I have a brief answer for it. Let us go with the age group also. So I call it as my age group, and over here also age group. Name is age group, right? I think, yeah, age group we have. Total records with respect to age group, total amount, age group, total amount with respect to total spendings, and average amount. This is the age group. So with respect to age group, we have the information. Same thing I like to have over here. Nothing changes so far, only the name changes, that we have a age group. Okay, and done. So total records of age group, with respect to that, I can see teens are the least in size. Teens and your, okay, we have two colors only. That's why we are not able to see clearly. Since in age group we have four values, so I have to make sure that we can do four colors over here. The next I like to keep red, and one more I like to keep orange, red, pink. Yeah. Hmm. So I can see teen is the least in value. Total amount spent teens is less. On comparing the average amount, you can see it is actually a good amount. Total amount spent by the middle aged adults is the highest, as they are also earning a lot and they are also taking care of their families. While average amount spent by seniors and middle aged adults and adults are almost same. So average amount spent you can see is very close. Seniors being the highest one. Okay, I hope you're loving this part of analysis. The third I like to bring on the basis of education. Okay, we have the highest number of people who are graduates, and while seeing the number of people, and PhD and masters are half of it, their average spend is almost equal to the graduate people's. PhD being the highest one. The total business given by the graduates are more, but the average is less as compared to the PhD. I have 5 values over here, so there should be 5 colors to support it. First, I will change the group name. And now one more color. We can add over here cyan, yellow, magenta. Yeah, magenta we have correct spelling. Done. We can clearly see on average PhD and graduates and masters are equivalent in size. Even second cycle is also equivalent in size. Second cycle is 5499. So as per the sliced area, we can see it's very much little higher. But yes, as comparing to the total amount, graduates are lot higher, and same to the number of records also. So request you to please go with the same pattern, go with the child group also analysis, and understand the relationship between it. Okay, I'm going to go further with the let's say I like to study. Okay, we'll go further with the analysis. Now I'm going to go with the modeling of the cluster. For this, I'm selecting the data set. Okay, my final data frame is equal to df dot drop, and after passing the list of the names, they should be in place equal to not in place. Sorry, because I'm saving it in already a different part, a different variable. I like to drop all maximum of the columns over here. So basically, what I'm looking forward to keep in my final data frame is the columns, few of the columns that I have created. Copy the entire list and ID I like to delete, year birth delete, education delete, marital status, kid income I like to keep, kid home, teen home I like to delete, DT of the customer I want it, recency delete, amount all of them, recency okay, also delete, no, keep it. So I would like to keep it for the final data frame. How much time have been spent since people have made the last purchase? The definition of recency. Amount, all of them I would like to delete because I already have the total spendings with me. Age group and age. Out of these two, I like to keep only age. Age group I don't want because we need only numbers for the machine learning model. So sorry, I like to keep age. Age group I'm deleting. So what I want income. I want my age. Year birth you want to keep, or you can drop that also. I have dropping it. Yeah, it's not needed because I already have my age. Kid home, teen home not required because I have my children's, so I will keep my children's. Total spendings I want, so that's why I don't want the other parameters. And months enrollment I want. I don't want the date DT of customer. Okay, so yeah, these are the important columns which I don't want to keep, and x is equal to 1. So my final data frame dot head of it is these columns. On the basis of these columns, these numbers, I like to perform my k-means algorithm. So from sklearn dot cluster import k-means. Also from sklearn import metrics, which can be helpful in my elbow method. Now, let's say my cluster range, I like to keep it as a range of from 1 to 21. Not even 1, I like to keep from 22 to 21. That is the range of the cluster range. And I like to store my inertia and I like to keep store my. So how the k-means work? Let's have a quick recap. My model is equal to k-means. Okay, model dot fit my final data frame, and then finally model dot labels. So this will perform the k-means algorithm and model dot labels. The labels that have been assigned. By default, it's 8 clusters they have kept. Okay, on the basis of 8 clusters, this is the final answer they have given to me. I like to analyze it's 8, but I don't have the time to go with 1, 2, 3 and going further. So I'm going to make a chart that is going to describe the number of clusters and the inertia with respect to it. So going further, for M in cluster range, my model at M is equal to k means, where n cluster number of clusters is equal to M starting from 2. My inertia range, sorry, my model M dot fit with final data frame each time and append the value of inertia for all of them. Yeah, okay, and I think that's it. Solving this will help us get the range of it, and we also know that this is for your initial k means plus plus. That is the mean. You can keep random also. Let's say keep random and make a chart. So plt dot plot. My x-axis I like to keep my cluster range, and on my y-axis I like to keep my inertia range. X and y. There is nothing like x and y. Directly plot it. Done. And over here, let us increase the size of it. Plt dot figure. Fig size equal to 1510. I can see that they have the values maybe 3 and 4. 3, 4, 5, they are being looking forward to the best ones. Why not to check it out simultaneously? What are the inertia range we have got? So print my list of cluster range and then print my inertia range. Okay, I can see that the values at 3 and 4. It's a vast difference, 3 and 4. For if I take random, if I take it as your k means plus plus only, so at that moment it's the same answer. So 3 and 4 same are the approach, and your I think I shall keep one more parameter over here that is called a Silhouette score. Matrix dot Silhouette score between the final data frame and your final data frame and your model m dot labels. Um, hmm. So Silhouette score keep on decreasing, and we can see clearly that out of two, 2 has good Silhouette score, but the inertia is very large. Keeping 3 and 4, you can see Silhouette score is nearly very close to them, and Silhouette score has a definition like how good the model has been performed in order to identify the best number of clusters. Over here, I can see Silhouette score since 3 and 4. 4 being more compact, and they are giving similar Silhouette score. So I like to keep the number of clusters as flow. Okay, number of clusters shall be 4. Now you require to submit this data set. So first of all, I will make a data frame for it. My predictions is equal to pd dot data frame. Over here, I like to keep my model labels and put the column as label. And finally, predictions dot to data frame or to CSV. My file name Nitesh dot CSV. Done. And over here, you have created a new CSV file. This is what we are looking forward for the submission. Index is also there, but don't worry, we will drop the index. Labels. We have not defined over here actually. Okay, let's quickly perform again k-means. So we can see 4 is the best one. So I'm going to perform over here. K means a number of clusters being 4. When number of clusters are 4, my predictions are for 4 labels, and also I like to keep my here it is okay. When I'm saving the results, make sure in index is equal to false. Done. Now open the CSV file. Here are all the labels that you have identified. Let's see. Predictions dot head. Why 11, 12 is coming? Let's check it out. Number of clusters is 4. Model dot fit. Actually, I'm taking model M, sorry. Now model dot labels. Now this will be correct. Yeah. So this is the correct file. This is what we're looking for the submission. Once I've identified this file, I'm going to match with the approach what is the sell out score you have received, how much you have identified the number of clusters inertia, and based on that, the winners are going to be selected. So this is what we have for customer personality hackathon solution. We have segmented the customer on the basis of groups. Even if you are getting a more fill out score, that will be the better. I will consider your approaches, go through with your all content, what you have done, and finally, I'm going to declare the result. So I hope you have liked the solution. Looking forward to provide you as much as more on this analysis, hackathons, and solution. So I will meet you in the next video. Till then, happy learning and take care.